Hello viewers, I am Kausalya. Today we are going to solve problems related with transients. The problem is, for the circuit shown in figure, find the currents I1 and I2 when the switch is closed at t equal to 0. Assume that the initial current through the inductor is 0. So here, there is no initial current through the inductor, right? And here we are requested to find the values of I1 and I2. So this is a given circuit diagram. It has two loops and it has a single source voltage. Let I1 and I2 be the currents that flow through the loop 1 and loop 2. Right. So the first step is, as usual, we have to apply KVL. So when you apply KVL, sum of voltage drop is equal to sum of voltage rise in a closed circuit. So here you see this resistor 5 ohm is common for loop 1 and loop 2. Right. And when you look at the direction of current that flows through this 5 ohm, you see here this current flows like this. That is I1 flows in this way and I2 flows in this way. That is in the opposite directions. Therefore, the voltage drop across this 5 ohm resistor is written as 5 into I1 minus I2. Since we are considering loop 1, right, we are writing the KVL for loop 1. Therefore, 5 into I1 minus I2, which is equal to the voltage rise is 20. So when you solve, I1 minus I2 is 20 by 5, which is equal to 4. Okay, let this be equation number 1. Now the next thing is, we are going to apply KVL to our loop 2. Right. So when you apply here, again 5 into, since we are considering loop 2, I2 should be written first. Therefore, the voltage drop across this 5 ohm is given as 5 into I2 minus I1. Right. Plus 10 I2 and again here 2 into di2 by dt, which is equal to 0 because loop 2 doesn't have any source voltage. Right. So this is our equation. Again, just we are multiplying and rearranging this equation. So finally, this is our equation. Right. Let this be equation number 2. Now we are going to take Laplace transformation for the equations 1 and 2. So when you take Laplace transformation, you see this becomes I1 of s minus I2 of s is equal to 4 by s. And when you look at equation number 2, minus 5 I1 of s plus 15 I2 of s plus 2 into s into I2 of s. Right. So these are the equations. Now now again we are going to write this in matrix form. So when you write it in matrix form, this is how our matrix is. Right. So the next step is, we are going to find the value of del. Right. So here del is nothing but determinant of this matrix. So when you take the determinant, I believe you people know. So just you have to multiply 1 into 2s plus 15 is 2s plus 15 minus of minus 5 into minus 1. So when you solve here, the answer is 2s plus 10. Now the next thing is, we are proceeding with del 2. So how to write del 2 here? You have to replace this second column by this value. So again just replace it and calculate. Here the value of del 2 is 20 by s. Right. So what is the formula to find I2? I2 is nothing but del 2 by del. So this is your del 2 and this is your del value. So just substitute it here. Again we always need an expression only in terms of s. Right. So here we are taking 2 outside. So when you take 2 outside, you see 20 and 2, the answer is 10. Therefore here this is our expression. Now the next thing is, we have to apply partial fraction. When you apply partial fraction, since the denominator has 2 terms, we have to write it as 2 individual terms. The next thing is, we have to find the values of a and b. Right. So when you substitute the value of s as 0, the value of a is 2. And when you substitute s equal to minus 5, the value of b is minus 2. Right. So now just substitute the values of a and b in this equation. So when you substitute here, you see this is our expression for I2 of s. Now the thing is, we need only I of t. That is, we have to take inverse Laplace transform. So when you take inverse Laplace transform, you see here this is our expression, right? 2 by s becomes 2 and here minus 2, 1 by s plus 5 becomes e to the power minus 5t. Right, this is your expression for I2 of t. Now look back at your equation number 1. So here your equation number 1 is I1 minus I2 is equal to 4 here. Therefore, here we know the value of I2, right? So the value of I1, it is nothing but 4 plus I2. So 4 plus, just substitute these values here, and once you solve, the value of I1 of t is 6 minus 2 into e to the power minus 5t, right? So finally we have find out the values of I1 and I2. Now we will proceed with the next problem. The problem is, for the circuit shown in figure, find the currents when the switch is closed at t equal to 0. So here this is the given circuit diagram. It has two loops and the respective currents are I1 and I2. Now we are going to redraw this circuit in S domain, right? So S domain means we are going to take Laplace transformation. That's it. So when you redraw the circuit, you see here the resistor values, they remain the same, and the inductor becomes simply S, because here it is of value 1, therefore it becomes S. And again when you take Laplace for this source, 5 remains as such, sin 20 becomes 20 by S square plus 20 square, and once you solve here the answer is 100 by S square plus 400. Right. Now we are going to write matrix expression. So here in matrix, as we all know, you see the sum of resistance in the first loop is 10 plus 5, 15, and here in the second loop is 5 plus S, right? And this 5 ohm is connected between I1, that is it is common for loop 1 and loop 2. And again when you look at the direction of current, you see I1 flows like this and I2 flows like this. They are opposite to each other. Therefore here it is minus 5, right? Then the respective currents are I1 of S and I2 of S, and the respective voltages are 0 and here 100 by S square plus 400, right? So here the thing is, we have to find the values of currents I1 and I2. So here the first step is we are going to calculate the value of del, right? That is the determinant of this matrix. So here the value of del is 15S plus 50. The next thing is finding del 1. Right, that is this first column is replaced by this source value, that is your del 1, right? So just substitute the values, and here the value of del 1 is 500 by S square plus 400, right? In the same way, just calculate the value of del 2, that is replace the second column by the respective source values, and here the answer is 1500 by S square plus 400, right? Now the value of I1 of S is, it is nothing but del 1 by del. So here we know the values of del 1, del 2, everything is calculated. So here just substitute the values, right? And again we always need only S plus some constant term, but here we are having 15 in addition. Therefore I am taking 15 outside. So when you take 15 outside, this is how our expression is, and again 500 by 15 is 33.34, which is written here, and the remaining terms remain as such, right? So the next step is we have to proceed by partial fraction. So when you go by partial fraction, since here we are having a quadratic equation, I am writing this one as bs plus c, right? Because this will produce two roots, right? Because the maximum power is 2. Therefore whenever you are having a quadratic equation, when you apply partial fraction, you have to write it as two terms, right? bs plus c. The next step is again take LCM, right? After taking LCM, you just multiply and split the terms. That is, you split it as S square terms and S terms and constant terms, right? So the first step is multiplication, right? A into S square, A square, A into 20 square, A 20 square. The same way, just multiply, right? Now here again I am splitting terms, right? So I am taking S square terms together, I am taking S terms together, and I am taking constant terms together. So after doing all these things, the next step is we are going to equate the coefficients, right? So here the equating coefficient of S square. So here the coefficient of S square is A plus B, whereas on the left hand side there is nothing. So A plus B equal to 0, therefore A is equal to minus B. The next step is equating coefficient of S, and here we don't have any S term. Therefore C plus 3.33B is equal to 0. Therefore the value of C is minus 3.33B. Right. The final step is we are going to equate the constants. That is 400a plus 3.33c is equal to, here the constant is 33.34. Right. So just equate it. The value of a is nothing but minus b and the value of c is nothing but minus 3.33b. So just substitute the values here. In the place of a it is minus b, in the place of c it is minus 3.33b. Right. So just multiply, solve, and finally the value of b is nothing but minus 0.081. So here, as we know, the value of a is minus of b. So minus of, just substitute the b. So the value of a is 0.081. Similarly, the value of c is minus 3.33b. Just substitute the values and here the answer is 0.27. Right. So now substitute all the values. So our I1 of s expression becomes like this. Right. The next step is I am going to split these terms and write. So when you split it and write, this is how our terms are. Right. So to this final term, I am going to multiply and divide by this constant value, that is 20. Right. So when you take inverse Laplace transform, it will be easier. So here s plus a, therefore e power minus at, and here this, it is s by s square plus 20 square, therefore cos 20t, and here you see 0.27 by 20 is 0.0135 and 20 by s square plus 20 square is sin 20. Right. So this is your expression for I1 of t. Now you proceed with I2. So how to calculate I2? I2 is given by del 2 by del. So just substitute the values. Okay, again we are going to repeat the same thing. I am going to take this 15 outside. And when you solve, this is our equation for, that is expression for I2. Again we have to apply partial fraction the same way. Since here we are having a quadratic equation, we have to write this as bs plus c. Right. Just take LCM. After taking LCM, right, this is our expression. Now again we have to equate the coefficient of s square, s, and finally constant. So when you equate the coefficient of s square, that is here there is no s square term, so it is 0. So a plus b is equal to 0, therefore b is equal to, sorry, a is equal to minus b or b is equal to minus a, both are same. Now again, when you equate the coefficient of s, the value of c is minus 3.33b. Finally, we are going to equate constants. So, similarly, substitute the value of a and c in terms of b. Once you solve, the value of b is minus 0.243. So, with the help of this b, we can easily find the values of a and c. Right. So, now again write it in the expression for I2 of s. This is our expression. Again, I am going to write these two expressions as individual expressions. Okay, I am going to split this expression. So when you split this, you see this is how it looks like. Right. So here the final term is, again this is 20 square, right? So it is multiplied and divided by 20, and when you take inverse Laplace transformation, here we are getting 0.243 e power minus 3.33t, and here it is 0.243 s by s square plus 20 square gives cos 20, and finally 0.81 by 20 is 0.04 and 20 by s square plus 20 square is sin 20t. Right. So here comes the end of this video. If you have any doubt, let me know in the comment section. Thank you.